Happy Halloween from the Allen Park Public Library. I'm Mad Dan. Today we're going to be looking at 3 Halloween themed experiments. We have a magic experiment, a spooky experiment, and an experiment with leftover candy. So let's get to them. This is our magic experiment. So we're going to use a AA battery, some very powerful magnets, and make some copper wire spin around. So here we have strong magnets. They are pushing a magnetic field out. Here we have a battery storing electric energy that pushes a current in one direction. We're going to attach the battery and the magnets together, and the magnets pushing in one direction, the current pushing in the other direction is going to generate a force. And let's see if the copper wire, which is conductive but not magnetic, feels that force. I would say yes. So the copper wire is now spinning on that force in a clockwise direction. What would happen if we change some of those forces? So we're going to stop it here. Take the battery off. Spin it around. Put the copper wire back on. And now it is spinning in a counterclockwise direction because the current of the battery is flowing in the other direction. All of those forces move in constant directions, but because we can't see any of the forces, it looks like magic. The last thing we're going to do is use the spin of the wire to turn this pumpkin into a jack-o'-lantern. This is our spooky experiment. We're going to use a candle, some water, and a jar, and we are going to put out the candle and cause the water in the jar to rise. So with a parent or a older sibling, you're going to light the candle, keeping it in the dish of water. We're then going to take an empty jar, glass jar, take the glass jar, put it over the candle, and then lower it into the water. Now, the candle is going to burn up all of the air all the oxygen that is in the jar, and then once the candle goes out, the water in the jar will rise up for a spooky effect. Now, while it is a cool little effect, it's just another example of the pressure and temperature that we were talking about over the summer. What happens is the candle generates heat, and the hot air cools on the glass. The colder air, once it cools down, is lower pressure than the outside air, and then the pressure pushes on the outside and pushes the water inside the jar up. This is the candy experiment. We're going to use chromatography in order to separate out the dyes that make up the candy shell on most common candies. So by using a drop of water, we can separate the colors out, put them on these coffee filters, and then use a saltwater solution to see how many dyes go into each and how many different colors. So join us next. Using a clean craft stick for each of the colors, you're going to take a little bit of each and just dab it onto the coffee filter in order to get that dye nice and thoroughly on there. And then while it's just one color right now, so brown, red, green, orange, yellow, and blue, we will quickly be able to see if those colors are pure or if they're multiple colors blended together to make that solid color. So now that we have a dot of color on each of the coffee filters, we have made a saltwater solution, just a tablespoon of salt mixed into some water, and we are going to stick the coffee filter into the water and let the filter, suck the water up, and separate out the dyes and see what happens. So after letting each of the papers sit for a minute or so in the water, we can already see some different reactions. The blue ran all the way up the paper, whereas the red stayed close to the bottom. And then if you look at the green, you've got yellow on the bottom, blue on the top. The brown is actually made up of reds and oranges, and they've all reacted a little bit differently. Now we use one type of candy for all of these. Feel free to use any candy with a hard shell and see if they all react differently, if they react the same, and what you can infer from all of that. Thank you for joining us at the Allen Park Public Library. I've been Mad Dan. We hope you have a spooktacular holiday.